So let's just move on and talk about the very first part under the coordinate geometry, which is nothing but the distance formula. So in the distance formula, we'll definitely discuss about the distance in between any two particular points which are lying in the xy plane. So for an instance, let us suppose if I'll take 2 points and the xy plane in such a manner. As you can see, we have the point A whose coordinate is nothing but 3, 2, and furthermore we have this particular point whose coordinate is actually nothing but 6 and 6, means from the x-axis its distance is 6, from the y-axis its distance is again 6. So now we just wanted to find out the distance in between these 2 points, means this line we just want to find out that what is the distance in between these 2 points. So as these points are actually lying in the xy plane, so it is quite an easy job for us to find the distance in between these 2 points. So first of all, let us suppose if I'm joining these 2 points and we just wanted to find out this particular distance. Let us suppose if I am taking a perpendicular distance from A and B in such a manner that I am extending the point A towards this direction till the point B, means let us suppose if I'm drawing a line of this particular manner, and if I'll see the distance of this point A from this particular point, then I can see that this is nothing but a total of a 3 unit distance. As you can see, the point A was actually on 3, so from 3 to 4, 4 to 5, 5 to 6, it is actually a 3 unit distance. Let's just further talk about from this particular point toward this particular point. If I'm drawing a straight line of this manner and let us suppose I'm calling it a point, then we can again further see that from this particular point till the point B, we can count the number of units. As you can see, the point B was actually on the number 6 and this point was actually on the number 2 on the y-axis. So we can count the units as 1, 2, 3 and 4. It means this is nothing but a 4 unit distance. This is nothing but a 4 unit distance. As you can see, you can compare it as the point A and this particular point, they are lying on the same straight line. So it means this is nothing but a 2 unit, or we can say this is nothing but 2. And if I'll count from 2 towards 6, so these are a total of 4 units. As you can see, from 2 to 3 it is 1 unit, 3 to 4 it is 1 unit, 4 to 5 it is 1 unit, and 5 to 6 is again 1 unit. So it means it is a total of 4 unit distance. So from this particular calculation, we can write it as, let us suppose this is nothing but A, and let us suppose I'm calling this point as nothing but C. Let us suppose I'm calling this point of intersection as C. So we can see that AC is actually 3 units and similarly BC is actually 4 units. So if we have drawn the perpendiculars from the point A and from the point B, then definitely this is nothing but a right angle triangle. And if it is a right angle triangle, then we can apply the Pythagoras theorem over here and we can find the hypotenuse of this particular right angle triangle. How it is? As we know that if in any right angle triangle which is right angled at C, then we can write that hypotenuse square is nothing but is equal to perpendicular square plus base square. So here we are aware about the perpendicular and the base as nothing but 4 and 3. So it means that we can find the hypotenuse as 16 plus of 9, which is actually 25. So h square is 25. It implies that h square is equal to 5 square, which implies that the hypotenuse is nothing but 5 units. So at the end, we have actually derived that the hypotenuse is nothing but of 5 units, and this is the distance in between the point A and B. So this is all about the distance formula, because we will definitely use the Pythagoras theorem in order to find the distance in between any two particular points which are lying in the plane. So let's just see all these calculations in the journal form and let's just derive the distance formula. So let's just derive the distance formula in journal. So let us suppose if we are taking the x-axis, y-axis and any particular 2 points which are lying on the xy plane and whose coordinates are x1, y1 and x2, y2. So it means we just wanted to find out the distance in between these 2 points. So let us suppose if I am joining the point P with the point Q, and in the same manner like we did before for that particular question, we will draw the perpendiculars from the point P and from the point Q in order to find the distance in between P and Q. So let us suppose if I am drawing a perpendicular from the point P and the perpendicular is nothing but on the x-axis, and let us suppose if I am calling it as nothing but any point R, and in the same manner I am drawing a perpendicular from the point Q as well and I am naming it as nothing but S. Let us suppose if I am taking another perpendicular which is from the point P towards the line QS. So let us suppose if this perpendicular is nothing but called as T. So this is again a perpendicular. So let us suppose if I am talking about the distance PQ. So let's just start with it. First of all, we can say that as the P's coordinate is nothing but x1, y1, it means that the distance of this point R from the origin. Let us suppose if I am talking about this particular distance. So this would definitely be nothing but x1. As you can see, this distance is nothing but x1. And similarly, if I'll move towards the S point, I can see that the S point is lying on the line which is joining this particular point, that is Q, whose coordinates is nothing but x2, y2, whose coordinates are x2, y2. So it means that the distance of the point S from the origin is nothing but a total of x2. This is nothing but x2. So if this whole distance is x2, this smaller distance, that is OR, is x1, then what can we say about this distance RS? So obviously this distance would be nothing but x2 minus of x1. Obviously, if this whole distance is nothing but OS is nothing but x2, this distance is x1, so this would be x2 minus x1. And in the similar manner, as we can see, this RS is actually coming parallel to B and equal to be this PT, because it is forming a square. So if this is x2 minus x1, then this would definitely be x2 minus of x1, or if it will be a rectangle, then definitely again this would be equal to each other. So hence we can say this PT distance, this PT is actually nothing but x2 minus of x1. And further, let us suppose if I am talking about the distance of Q and S and T and S. So in the same manner like we did for the x1 and x2, let's just talk about y1 and y2. So as we can see over here, this particular point T is actually at a distance of y1. This is actually at a distance of y1 from the x-axis, and furthermore this point Q is actually at a distance of y2. This is actually at a distance of y2 from the x-axis. So if this whole distance is y2, this smaller distance is y1. So QT distance, as you can see, the QT distance would be nothing but y2 minus of y1. This would be y2 minus of y1. As you can see, if this is y2, this is y1, so this would be y2 minus of y1. Now you can see that as we have taken PT as nothing but a perpendicular, as we have taken this is nothing but as a perpendicular, so we have formed a right angle triangle, that is PQT, which is right angled at T. So we can say that in the triangle PQT, by using the Pythagoras theorem, we can say that PQ square is actually equal to PT square plus of TQ square or QT square. We can write this because hypotenuse square is definitely equal to perpendicular square plus base square. Now just plug in all the values that we know about PT, QT and PQ. So as we just wanted to find PQ distance, so this is PQ whole square, which is equal to PT. What is the value of PT? PT is x2 minus x1 whole square plus QT is nothing but y2 y2 minus of y1 whole square, and we just wanted to find out the value of pq. So pq would be nothing but square root of, it will take square towards the other side, so it would be square root. So this is x2 minus x1 whole square plus of y2 minus y1 whole square. So this is nothing but the distance pq, or the distance of a point p from the point q. And many a times we also write it in the formation of a mod as it cannot be negative, so it is always positive. So we always take PQ in this particular formation, or we can say the mod of PQ, which is nothing but is equal to square root of x2 minus of x1 whole square plus of y2 minus of y1 whole square. So this is actually nothing but called as the distance formula in general, and using this particular formula we can find the distance in between any two particular points. So let's just write this information in general. So PQ, which is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square root, is called as nothing but the distance formula in between any two particular points P and Q in general. So using this particular formula, now we will solve a lot of questions. So let's just move on further. So as we are already aware about, the distance formula is actually nothing but square root of x2 minus x1 whole square plus of y2 minus of y1 whole square. It is called as the distance formula. So there are some of the remarks that are related with this distance formula. So let's just talk about these remarks. So first of all, the very first remark says that the distance of the point from the origin. So if we are taking one of the coordinates of a point as nothing but on the origin, means the coordinate should be of the 0, 0 formation, then the distance, that is OP distance, would be of the form square root of x square plus y square. You can also plug in the values in the distance formula as well, because let us suppose if I'll take x and y as nothing but x2 and y2, and if I'll take x1 y1 as nothing but 0, 0. So if I'll plug in x1 y1 and x2 y2 in this particular formula, so I will get x minus 0 whole square plus y minus 0 whole square, which is again x square plus y square whole square root. So always remember, whenever we are talking about the distance of a point from the origin, then it is always nothing but square root of x square plus y square, and distance cannot be negative, it is always positive. Always remember this particular fact. Now let's just talk about the second one. The second one says that PQ distance can not only be written as x2 minus x1 whole square, but we can also write it in the formation of x1 minus x2 whole square, because both of these values are equivalent to each other. These are equivalent to each other because x2 minus x1 whole square is just same as that of x1 minus of x2 whole square, and in the similar manner y2 minus y1 whole square is just similar to that of y1 minus y2 whole square. So you can also remember this distance formula in this particular form. So these are the two important remarks that are related with the distance formula. Let's just further move on and talk about the collinearity of the points. What is the meaning of collinearity of the points? But before that, let's just talk about the collinear. So we'll say any points that are lying on the same straight line, they are said to be collinear. They are called as collinear. So here we just have to verify whether the points are collinear or not. So using the distance formula, we can check whether the points are collinear or not. So we'll say if 3 points we have A, B and C, we can say that they are collinear if they will satisfy a particular condition. And the condition is AB distance plus BC distance should be mandatory is equal to the AC distance. So for an instance, if I'll draw the points A, B and C over here, let us suppose we have the point A, we have the point B and we have the point C over here. So let us suppose if I'll join the points A, B and C. So we'll say that these points are collinear, means they are lying on the same straight line if the distance of AB, means the distance of AB, that is distance AB plus of the distance BC. We are talking about the distance BC. We'll say if the distance AB and the distance BC should comes out to be equal to the whole distance that is nothing but AC. which is nothing but AC. So it is a general fact, as you can see over here. It is quite an obvious thing that if AB distance plus BC distance comes out to be equal to the whole distance, that is AC, then these points are called as collinear, means they are lying on the same straight line. So this is about the collinearity of the points. Let's just move on further and talk about some of the questions that are related with distance formula.